Hello everyone, today I'm excited to share some codes for a simple CNN model implemented using the Fashion MNIST dataset. Fashion MNIST is a well-known image classification dataset that contains images of clothing items from different categories. I'll be using TensorFlow, specifically its Keras API, to perform image classification. To get started, I've imported the necessary libraries, TensorFlow, NumPy, and Matplotlib. Using the Keras API, I've loaded the Fashion MNIST dataset. I divide the loaded dataset into train and test datasets and store them in separate variables. And I also stored the images and labels from the training and testing datasets in separate variables. So you can see that the loaded data is stored in a total of 4 different values. Now let's take a moment to check the data. We'll look at the shape of the data and also examine some actual data samples. As we can see the result here, there are a total of 60 images, each with a size of 28 by 28 pixels. Okay. So let's take a look at the first image data. We can see that there is one list containing 28 lists, and each of those lists has 28 values, confirming that it is indeed a 28 by 28 pixel image. Each value in the image represents the color of the pixel. A value of 0 represents black, and as the values increase up to 255, the image becomes progressively lighter. So we can tell in this wrist, we can tell that this part or this part, these parts will be the lighter areas in the image. And for convenience, I've also created a label list that corresponds to the different categories. So you can see the t-shirt, trouser, pullover, like this. And I'll use the image show function from Matplotlib to visualize the grayscale image. Now you can see the image along with its label, which is ankle boot. So we just finished checking the data. However, since there are pixel values ranging from 0 to 255, the differences in magnitude could lead to overfitting. Thus, we need to normalize the values to reduce the scale. Typically, we perform scaling so that the values range between 0 to 1, 0 and 1. In this case, we'll divide by the maximum value. Here, 255. Okay, next step. Now let's proceed to design the CNN model that can classify the images using the actual data. I'll utilize the TensorFlow library here, okay, and the Keras API to stack variable layers and build a deep learning model. There are 2 ways to build a model, and in this case, I've chosen to use the sequential API to stack the layers in order, storing the model in a variable called model. Let's dive into the details of each layer. Here, first, we added a convolutional 2D layer to our model variable. In this layer, we use a kernel to extract features from the image. So what exactly is a kernel? A kernel is a small filter designed to extract features. This kernel is applied across the entire image to detect essential characteristics for image classification. Looking at the code again, we see key arguments such as filter, kernel size, activation, input shape, and padding being set. This layer applies 23 filters of size 3 by 3 to the input image, which has a shape of 28 by 28 pixels with one channel. Essentially, we set the filter size to 3 by 3, multiplying the pixel values of 3 by 3 regions with weights to produce a single output. We chose 23 filters initially to capture basic features like lines and curves, gradually increasing the number of filters as we go deeper to detect more complex characteristics. And for the input shape, color images are typically entered as 3D arrays, but for a grayscale image, we treat them as 2D pixel arrays with a depth of 1. And the activation function used here is ReLU, which stands for Rectified Linear Unit. It introduces nonlinearity and helps avoid vanishing gradients. Finally, the padding is applied because edge pixels are less likely to be computed as frequently as those in the center. I set the padding to same, and it ensures that the output retains the same spatial dimensions as the input by adding zero padding. Okay, so from the next step onward, I will explain in the second video due to time constraints. So please check out the second video where we design the model and review the results. Thank you for watching.